about that. Please go ahead and read 66. Problem number 1.
Wait, one or like A through B?
Just read number 1 and A.
66?
Yep, 66. We had a lot of confusion on this today. So read 1 and A. Just to when you are finished, go ahead and talk to your partner about what do you know. What are they giving us? Okay, go ahead and talk to your partner about that. Go ahead and work with.
Left terminal, but what I don't know is I don't think they give us the distance between the west terminal and the east terminal. So I think we would probably add these two together.
Bam, Max, that's awesome.
Yeah, and I would say, and we know it's coming at 10 per second. So all we have to figure out that to go the entire distance, so it's simply.
Okay, so I've heard a number of great things that we know. Okay? Oops, I moved that too soon. We know that the train is going at 10 meters per second. I didn't. Oh gosh, I gotta move it again. So, if we know the train is going at 10 meters per second, we know quite a bit actually. How far has it gone in 2 seconds?
20.
So in 2 seconds, 22 seconds, 20 meters. 3 seconds, 30 meters. Okay. This equation is the equation that you need. The equation is, here I have a rate times a time. And what does that give me?
Distance traveled.
My distance. Okay. So this equation is really important. And you got that just from knowing this. You're like, oh, in 10 meters per second, in 2 seconds, 20 meters, 30 meters. So you know the rate as well. So we know these, but we also know this. Rate times time equals distance. Very important. You need to know this for today. I was listening to Max talk about the picture. Max hit around the head. He's like, hey, it's giving us a 0 meter, -1,000 going west, 1,500 going east. And then Max and Liam both were talking and they said, well, the total distance between these two is 2,500 meters. Good. That's another thing that we know. There are 3 terminals and we know the distances between them. Anything else that you guys shared that we don't know or that we do know? Okay. So here we have a train. It's leaving the terminal at 10 meters per second. And it asks, where will it be in 10 seconds? So here I'm going to go back to my equation that we came up with, which is my rate, 10 meters per second.
What terminal is it going to and what
time? Times time equals my distance. So it's saying a train leaves the main terminal going east, so it's going this way, okay, at 10 meters per second, where it will be in 10 seconds. So my rate is 10. My time is 10. So what's my distance? 100 meters. Now I could also say 100 meters going east. Because it is. It's 100 meters going east. The next question says, when will it reach the east terminal? So here's 0. Here's east. Let's go back to I have rate times time equals distance. I know the distance, 1,500. Do I know my time? Nope. We're going to call time t. Do I know my rate? Yes. So I know that this is true. 10 times this is going to equal that. So time is going to equal 1,500 divided by 10. So then I know my time equals 150. And what is that 150?
150 seconds travel.
Seconds. So when will it reach there? In 150 seconds. I could also call that 2 minutes and 30 seconds because it's the same thing, right? I could divide that by 60 and get 2.5 minutes. So now that you know this, okay, I would like you to go and tackle D. Tackle D with your partner.
Tackle D? Okay. What's that 10 meters per second? When was it at the east term? Where was it? Travel was it to get so from here to here it's 150. Where was it 20 seconds ago in 150 seconds right to get from here to here? Oh yeah. No, all we're going to do is 150 seconds from here to here. 150. 130 seconds. Now we just need to do 10. 130 divided by 10.
130 seconds is 1,500.
Because so it started here and it went to here, and the total distance the time traveled from here to here is 150 seconds. And where it's asking where was it 20 seconds ago?
No, where will it be in 20 seconds?
Oh, okay.
No. It's where was it 20 seconds ago?
No.
Yeah, no, Max is right. It's where was it?
So we just need
Different kind of question.
We just need to do the total time traveled subtracted by that. Now it gives us 130 seconds, and then we just need to do 10. 130 divided by 10. Which would be... Yeah, that's what I'm saying. And it's asking how, where was it 20 seconds ago? So if it's 150 from here to here, 20 seconds ago would be 150 for the total time travel minus 20 because 20 seconds, 20 plus.
Okay, let's come back together. This is a more difficult question. You're still using rate times time equals distance. But there's definitely some confusion in here. Where is the confusion coming from? Ben?
Where the train was.
Where it was. And when it says 20 seconds ago. Okay, so here a train passes the main terminal going west. So it's passing the terminal going this way, right? At 10 meters per second. So our rate hasn't changed. When was it at the east terminal? So if it passes here, going at 10 meters per second, when was it here? So 150 seconds ago. How would we show that as a number? Negative 150. Okay, because it's going this way, so this distance is now negative, right? So the way it would look is you would have 10 times t equals negative 150. I still do the same thing. I divide both sides. I divide this side by 10. Okay? And that's going to give me my negative 150 seconds. Because this distance is now negative because it's now behind. Does that make sense?
If it's asking us where we were 20 seconds ago, wouldn't we need to, we would have to subtract the 20 seconds from
We're going to talk about that.
50 travel.
You're going to, yes, next one. Where was it 20 seconds ago? So now we have to go back and we have to figure, well, 20 seconds, how far does the train travel in 20 seconds? 200 meters. So now I got to take my 1,500 and I have to add a negative 200, which is like subtracting a positive, right? And that's going to give me an answer of, it was at 1,300 meters, or would be another way to say that?
1,300.
Could I say negative 200 meters? You could say it. You could say 1,300 meters, right? From here, I could say 1,300 meters from the east terminal going west, or I could say negative 200 meters. So those are, and I have that right there. But that's a difficult question. All right, go ahead, put this away. Today, I'm going to go back to the main page because today is all about this. You guys, please be hyper aware of what the adding and subtracting algorithms are, right? And what the multiplication and division algorithms are. Hyper aware. Because today the problems you're going to do is going to go back and forth. So don't get confused. Use the anchor charts. Use your notes. Because I want you to really do a good job today at understanding what are the algorithms for rational numbers when I multiply and divide. What are the algorithms for rational numbers when I add and subtract? Questions about that? So, now that you've got that, today, this is what you're tackling. I will come around. I'm going to support you guys. Page 74, problems 55 through 60. For question 60, you only have to show me 10 different sums. You see, they're all, the whole time today, they're going to use the word quotient, sums, difference, product, and you need to know what those mean. Don't get them confused. Okay, so if you hear the word sum, adding and subtracting algorithms. If you hear the word product, multiplication and division algorithms. James. Okay, hold on. I'll come by and answer that. Go ahead on a new piece of paper, preparing for the test on Monday, because that's what you have on Monday is that test. Okay, that should be your title. This is going to go in your learning. Okay, this work today. Cam's already writing down the title. And you can get going. All right. You could. 1,500 meters is a long way. You know? Pretty far. It's almost a mile.
58 and 59. I don't know what it's asking.
It's asking for a story. So it'd be like Joe had 2 apples.
I can do 59. I don't understand 58.
Yeah. Think about what.
No, it says.
What real life things are negative?
No, but that's not what it is. I can say for 58. The 58, like the number problem, he's showing doesn't make sense to me, but it's not a number problem. It's just saying it's something 40.
No. Oh, I see what you're doing. So it's -4 times n.
That's not what it says on the thing.
You don't do that right. He's just not quite understanding that the n means it's a variable as opposed to times it.
What? No.
He's never seen it before.
It's saying -4 times 10.
No, but it never shows you multiplication.
Right, even when they're like this, you have a variable like this.
There isn't a variable. It's a number.
If you put 2 in for n, would it equal to?
Yeah, I'm missing.
No.
So let's hold on. Let's look.
Nothing will equal -24 because it's already why multiply what times 6? How are you multiplying it? It doesn't say there's a multiplication.
So,
Let's do 2020. That's rich. You took it twice, though, right?
Yeah.
That's your first one.
No, so that means
There's Liam's second
4
one.
times 40 is -24.
Okay, you never got it.
remember up there?
So just take it again. Do it tonight. Just do it tonight at home. Take it again. And
I mean 6.
if you try, because you tried to save it.
Yeah, so,
You got, anytime you take those, you have to submit. If you don't submit, everything's gone.
Okay, well that's good to know.
Yeah, anytime you get those Google forms, you can't save.
Yeah, and what you did in your head is you took
but how, I don't know, that don't really seem practical to me because you could just use a positive number for it and more like other sources data generally kind of then unnecessary.
I kind of agree, but there are two things that negative numbers come in super useful all the time.
But you could have just
Money,
you could have
debt,
I know.
and temperature.
You could just say you could still use that as a positive number and just call it and just say
Yeah,
debt.
not temperature, you can't.
really messed up.
Yeah, temperature,
That's what I'm saying.
because think about
What-
negative, you get a temperature of -10. There's no way to say that. I mean, you could say 10 below 0.
You could just write it up and down and below.
Keep studying and then you'll come up with a new system that will wall it out.
All of them.
Call it the Swivl system. Trying to smile that.
Yes. Okay, I'm coming around. Yeah, let's go. Let's work
It
on
does
it.
look, you'll see that from now on.
I think the statement is that true or false? Right, so 0 is the additive identity, because if I add 0 to anything, what do I get? The same number. So is this a true statement? -1 equals -1 plus 0. Are those equal to each other? Yeah, so it's true. Yep. Yeah. Oh, you did it. Nice. Okay. Multiplication. So here's the tricky part with that one.
Wait,
It's not asking you to solve for n. It's asking you to write a number story that represents that.
Does a number story have to be
Okay,
the same
good one.
like that? Or can it be like that, then that, and then different? Like, does it matter the order of numbers?
Now that you give it.
Okay.
Okay. You know that's the answer, right? So how do I write a number story where it basically is telling me I'm going to have a negative number, which could be temperature, or Michaela has a gambling problem.
Yeah, that's right. This is gambling problem.
Yeah, Michaela has one. And you lose money all the time gambling. $4 to be precise. And then at some point you owe negative 24. So think about how to write that way. Now this one I feel is like easier, but it's got to be stated like division, not multiplication. Okay. It's not asking me to do that. It's asking me to say like, okay, let's say I owe Orlando 4 apples. How many apples is that? 24. So I owe Orlando negative 4 apples. At the end of the week? No. At the end of so many days, I owe him negative 24 apples. So every day I owe Orlando negative 4 apples. After so many days, I owe him negative 24.
Okay,
What would be that? And what would be the question? How many?
Okay.
It's tough. It's a tough question. Orlando's a good apple. Yeah. Where's that equal? This side. Yeah. You get it? Nice. Nice. Okay.
Yes.
So it's 55 through 60. So this is step 1. Right. So money and temperature are 2 things that we use a lot of in debt. She owes her friend $4, right? Every day. Every day she owes her friend $4. At the end of so many days, she owes her friend $4. How many days have passed? See that? Does that make sense? Nice. Not getting too confused on 57 so far. Try to keep these in order. Put this stuff away like if I give you time, I say, hey, put that in there. Put this in your home. Just that. Okay. And you this you can put. is just showing you it's negative. That's it. And so it's just saying this is negative 3/4. 8 divided by 2 is not 60. Okay. So remember, with a fraction, this equals this. And this also equals, top dog always gets the dog house. So it also equals that. Does that answer your question? That's how you find the decimal. Can I check the word on this side? On which? 60? Okay. So if you notice on 60 I said 10 different sums. You have 2 paper clips, right? And you know that you can put those 2 paper clips anywhere. So one sum I could say is negative 22. How could I get that?
So you do how you get that, or you do the sum?
How do you get it?
Okay.
So you put the sum and how do you get it? Does that make sense? You just need 10 of them. The only thing is these 2 add-ins can't be the same because I can't take my paper clips and put them on the same number. That would be 2 different numbers. Okay? No. Okay, yes. So think about it. A negative plus a negative is like subtracting a positive. Where do I go when I subtract a positive? Left. So if I have a negative and I go left, it becomes even more negative. Like, no, it's not going to be positive. It's going to be negative 6 plus negative 0.75 or negative 3/4. So what am I going to get? I'm going to get a small, right? One that's further from 0. So think about what that is then when you compare it to what I have. Is it different than that? Yes. No. It's the same. I have negative 6 plus negative 3/4. What is negative 3/4 as a decimal? 0.75. But it's negative 0.75. Dude, those are the only 2 that's first. Now 57. They're totally. It's a negative plus a negative. It's a positive. So you have to write a number story. Write a story problem. Yeah. Yeah. It's the same thing, right? There's 3, and I can have that. These are all equivalent. Every single one of these are equivalent. This equals this equals that. Every single one of these are the same exact thing. Here it's a negative. There, this is a negative. There it's a negative. Now, if I have this, this is positive because it's a negative 3 divided by a positive 4, which a negative divided by a negative equals a positive. So this actually equals.
Are we doing the sum game thing?
That. But yeah, these are all the same. They're all equivalent.
Are we doing the sum game? Right here.
Yeah, that's what it asks you to do. Yep, the sum game.
So we do this with the
Well,
partner?
no, we don't do it with a partner. Your job is to show 10 different sums.
No, it says you need 11 numbers.
Figure it out.
Yeah, we're just doing 10.
Yeah.
All right.
And what? different sums, so I could just hit circle in 10 different boxes.
Right, but then you have to show me how to get those boxes. So if negative 22 is one of your boxes, how do you get it? These two numbers. Now you gotta tell me the sums. 10 sums. Yeah. What would be the sums of your numbers? So it's like negative 6 plus negative 5 would be the sum. Yeah. Boom. Good job. He was in Man, you're really close. So remember, a multiplication problem means that the same thing happens so many times. Right. So here, you know that negative 4 happens how many times? 6 times. But that's the answer to your question. So you see, you're almost there. It says he's in debt $4. For the next X amount of days, he goes in debt the same amount. In the end, he owes negative 24. How many days did he go in debt? Does that make sense? Because that's what you're almost there. That's a really hard question. Come on, Kim. You skip the 2 hard ones? Okay. Dude, this is so close. Okay. The thing is, this number sentence, there is no 32. You know it's 32. But that's what they're asking you. You see what I'm saying? It should be in the end like, so what you're saying is, John has 32 pieces of apple, right? He split each apple. No, that would be wrong. That's not the right number set. Yeah. So yes, James has 16 apples. Hold on, no. It's got to be a division.
I think James gave me 16 apples.
He
gave me half of his apples, which is 16. There we go.
James gave me half. No, James gave me half of his apples. He had 16 apples. That's how many pieces did he give me? Yeah, it's not. Both of those questions are hard because it's asking to find the quotient.
We didn't. If you gave me 16,
all right, let's go.
Half of them, then you still had 16.
Can I share someone's word problem for 59 and 58? Because this is by far the most difficult part of the test coming up. All right. Oh, it's on freeze. All right, so this is Maya's. Boy, I have a hard time reading that, huh? Now I know where it is. I'm going to zoom in. So here's the number sentence, and I like her number sentence. Now, we know that this number story has to have some sort of multiplication in it. And we know that multiplication is something that happens, the same thing happens multiple times. So Molly has to pay $4 a week for someone to mow her lawn. This is great. So $4 per week. So it's like she owes $4 every single week.
Yep.
After a few weeks, she's paid negative $24. How many weeks has gone by? That's pretty good.
16.
Now,
more than a few.
to make this a little bit better, it should say she has to pay someone $4. Okay? She paid them $24 ahead of time, which would be a negative 24, right? Like she's lost $24. She paid them ahead. Let's look at 59. Lily has a certain number of snails in a jar. After putting half of the snails in a tank, perfect. She's got this jar of snails. She takes half of them, which is dividing by. Do you really have snails? Okay. Then there are 16 snails in the jar. This is great. This is perfect. She's taken a number, dividing it by 2, and then she's left with the number. So the question is, how many did she start with? Perfect. This is like quintessential perfect question. What is the original number of snails? So you notice, in her first one, she has a multiplication problem. In the second one, she has a division problem. That is one of the hardest things to do when you're given an equation, to make sure that the way you write the equation is asking for the variable that it's showing. That's difficult sometimes. Like a lot of you, I know Jacob, he wanted to solve it. So he solved it. He's like, I got 32 apples. I give half of them away. I have 16 apples left. But it's not, 32 was supposedly the number you needed to figure out. They didn't want you to give it to them. Okay, go ahead, put this in your learning. Please get your planner out. Whoops, where'd it go? I closed it. Okay. Okay. Before we start, remember with your planner, if you come to me, you say, "Hey, Ms. McFarland, I'm missing some work." I say, "Sweet. Okay, no problem." Open up your planner. You open up your planner. You've got almost all the days filled in. I will so help you, and I'll just be like, that one, this one, turn it over, that one, this one. You've done your work. I will help you figure out any confusion. Second scenario. Ms. McFarland, missing a bunch of work. Can't we figure out work? No problem. Open up your planner. Open up your planner. You got like a day here, a day there maybe. You turn it over, no days. My job isn't to do your work. I'll say, hey, I got all the dates online. Go to Google Classroom, get your planner out, fill in your homework and then that will tell you exactly, and then I'll tell you what you owe. Your job is to do that. My job isn't to do that for you. And I will not. So just when I tell you to fill in your planner, do it. Okay, your homework for tonight. Complete the sheet that I passed out. It's also on Google Classroom. So let's say you got home, you forgot it. Go to Google Classroom, it's right there. Boom. Homework for tonight, October 3rd. I put that piece of paper, I scanned it, and it's on there. This is your exit ticket. If you notice, multiplying. by rational numbers. Subtracting rational numbers. Dividing rational numbers. Adding rational numbers. That's what today was all about. Using all these operations and understanding these algorithms go with this, these algorithms go with that. I would copy down A, B, and C. Copy them down, Max. Get them down. A, B, C, and D. Copy those down. And you can finish it tonight. But make sure you copy them down. Okay? I will be collecting the warm-up and exit tickets tomorrow. So please make sure you do this. You can stay and finish. Okay? Or if you choose, you can leave. If all you have is the problems down, you're going to lose a lot of points. So make sure to take the time. I'm giving you time right now to do it. Well, you don't really need to go, but no, you don't. But that's okay. You can.
I want to go.
That's different than needing. They're two different things. I'll call a kettle black when the kettle is black. Needing and wanting are two different things.
That's racist.
That's what? That's what? If a kettle's black and I call it black, that's racist? Very interesting.